Hello and welcome to this video. In this video I am going to define and describe the time value of money, and I request you to watch this video completely because after watching this video you will be able to understand what is meant by the time value of money, understand the relationship between present and future value, how to calculate both future and present values. You can distinguish between an ordinary annuity and an annuity due, and how to use interest factor tables and understand how they provide a shortcut to calculating present and future values. Let's start by defining the time value of money concept. If I ask you, which would you prefer, 1000 today or 1010 years from today? Common sense tells us to take the 1000 today because we recognize that there is a time value of money. The immediate receipt of 1000 provides us with the opportunity to put our money to work and earn interest. So now what is interest? Interest can be defined as the money paid or earned for the use of money. Now let's define the simple interest. Simple interest is the interest that is paid or earned on only the original amount or principal borrowed or lent. The dollar amount of simple interest is a function of three variables. Number first is the original amount borrowed or lent. Number second is the interest rate per time period. Number third is the number of time periods for which the principal is borrowed or lent. A simple formula or equation can be derived. Simple interest is equal to principal multiplied by interest and multiplied by number of time periods. This is the formula to calculate simple interest. And now the compound interest. Compound interest is the interest paid or earned on any previous interest earned, as well as on the principal borrowed or lent. It means interest on interest. So future or compound value of a single amount can be calculated using this particular formula. Fv is equal to P naught multiplied by 1 plus R power T. So for this, consider a person who deposits 100 into a savings account. If the interest rate is 8% compounded annually, how much will the 100 be worth at the end of a year? We can solve this problem with the help of above formula. Here P naught is 100, whereas interest rate is 8% and power T, that is time period, that is 1 year. So by solving this calculation, we can get the answer of 108. That's very simple. Let's take another example. Let's calculate the future value, but now the time period is 2 years. So the answer we are getting is 116.64. This is the additional interest is earned due to compounding effect. The additional 0.64 cents we earned is due to compounding effect. So here the general formula for future value or compound value of a deposit at the end of n periods. So here the factor that is multiplied with the principal amount is called as future value interest factor. Now let's define the present or discounted value. Finding the present value or discounting is simply the reverse of compounding. Therefore, let's first retrieve from future value equation. Rearranging terms, we can solve for the present value. And again, the term 1 divided by 1 plus I power n is called as a present value interest factor. Whereas for future value interest factor, I already told you about that. And now the future and present value interest factor tables. You know that future and present value interest factor tables help you locate the appropriate interest factor. These are calculated values that you can simply put in the present value or future value equations and you can have your answer. This is the future value interest factor table. As you know that this term here is future value interest factor. So that's why it is the table for future value interest factor. And now I am going to tell you how can you locate your desired value. For example, the future value interest factor at 8% for 9 years is located at the intersection of 8% column with the 9 period row and equals 1.999. We can simply put this into the equation and get our answer. And now I am going to tell you how you can calculate unknown interest rate or discount rate. If it is not given in the problem, sometimes we are faced with a time value of money situation in which interest rate is unknown. For example, let's assume that if you invest $1,000 today, you will receive $3,000 in exactly 8 years. The compound interest or discount rate implicit in this situation can be found by rearranging either a basic future value or present value equation. You can calculate it using basic future value or present value equation. So let's do it. This is a simple future value equation. So we can put our given values here. Fe is 3000, P0 is 1000 multiplied by 1 plus I, that is unknown, and power 8. So by shifting 1000 towards the other side, that will be 3000 divided by 1000 and we can get 3. And after this we have to shift the exponent or power to the other side. And as you know that in mathematics, if you shift the power towards the other side, it will reverse itself. It will be 1 divided by 8. When you solve this 1 divided by 8, you are going to get 0.125. So 3 power 0.125 will be 1.1472. And in last step, this 1 over here is shifted towards the other side and that will be negative. So the answer we get 0.01472, that is 14.72%. So that's how you can calculate the unknown interest rate if it is not given in the problem. Now the unknown number of compounding or discounting periods. Sometimes we may need to know how long it will take for a dollar amount invested today to grow to a certain future value given a particular compound rate of interest. For example, how long would it take for an investment of $1,000 to grow to $1,900 if we invested it at a compound annual interest rate of 10%? So now we can calculate the number of periods using simple present or future value equations. Again, same future value equation. Fe is equal to 1900, whereas P0 or present amount is $1,000 multiplied by 1 plus I, that is given, that is 10%, power n, that is unknown. We have to calculate that. So by solving this equation, we get that 1 plus 0.01 power n is equal to 1.9. As you know that natural logarithm is the reverse of exponent. We can use natural logarithm to shift exponent as a number, to shift it from here to down here. So n multiplied by natural logarithm 1.1 is equal to natural logarithm 1.9. And by solving this equation, we can get our answer, that is 6.73 years. That's very simple. So that's all in this particular video. I hope you understood what I defined and described in this video. Thank you so much for watching.